Welcome to Grade 7 Mathematics. In this lesson, we explore triangles and congruence, the shapes that hold our buildings together, and the rule that links their sides. By the end, you will classify any triangle, use Pythagoras' theorem to find a missing length, and decide when two triangles are exactly the same. Here is our plan for the lesson. We sort triangles first by their sides, then by their angles. We meet Pythagoras' theorem and use it to find a missing length. We test whether a triangle contains a right angle, and we finish by deciding when two triangles are congruent, that is, exactly the same in shape and size. Every triangle has three sides, and the first way to sort them is by the lengths of those sides. A scalene triangle has no equal sides. All three are different lengths. An isosceles triangle has exactly two equal sides, which we mark with matching ticks. An equilateral triangle has all three sides equal, and because of that, all three of its angles are equal too. The little tick marks on each side tell us at a glance which sides match. Once we know the sides, we can also sort triangles by their angles. The second way to sort a triangle is by its largest angle. If all three angles are less than 90 degrees, the triangle is acute. If one angle is exactly 90 degrees, a square corner, the triangle is right-angled. We mark that square corner with a small box. And if one angle is greater than 90 degrees, the triangle is obtuse. Remember that a triangle can have only one right or obtuse angle, because its three angles together can never pass 180 degrees. The right-angled triangle is special, and it leads us to Pythagoras' theorem. A right-angled triangle has one special side. The side opposite the right angle is the longest, and we call it the hypotenuse. Pythagoras' theorem links the three sides in a beautiful way. If we build a square on each side, the area of the square on the hypotenuse equals the areas of the squares on the other two sides added together. In symbols, a squared plus b squared equals c squared, where c is always the hypotenuse. This single relationship lets us find any one side when we know the other two. Let us put the theorem to work and find a missing side. This right triangle has legs of 6 and 8, and we want the hypotenuse, c. By Pythagoras, c squared equals 6 squared plus 8 squared. 6 squared is 36, and 8 squared is 64. Adding them gives 100. So c squared is 100, and c is the square root of 100, which is 10. The hypotenuse is 10 units long. Pythagoras also works in reverse, and this is useful for builders. Take a triangle with sides 5, 12, and 13. We test the two shorter sides. 5 squared plus 12 squared is 25 plus 144, which gives 169. Now the longest side, 13 squared, is also 169. Because the two results are equal, the triangle must contain a right angle. This is how a carpenter checks that a corner is truly square. Two triangles are congruent when one fits exactly onto the other, with matching sides and matching angles. The matching ticks here show that every side of the first triangle equals the side it matches in the second. We do not have to check all 6 measurements. 4 short tests are enough. If 3 sides match, that is side, side, side. If 2 sides and the angle between them match, that is side, angle, side. 2 angles and the side between them give angle, side, angle. And for right triangles, a matching right angle, hypotenuse, and one side is enough. Any one of these tests proves the triangles are exactly the same. Triangles are everywhere in the world you live in. A triangle keeps its shape under pressure, so it is the strongest shape we can build with. That is why roof trusses on Kigali homes are braced with triangles, and why bridge frames are filled with them to carry heavy loads. A builder who needs a perfect square corner measures 3 units along one edge and 4 along the other. When the diagonal reads 5, the corner is exactly square. Surveyors marking out farmland rely on congruent triangles to copy a measurement from one place to another. These shapes quietly hold up the world around us. Before we practice, let us avoid the traps that catch most learners. First, Pythagoras' theorem works only in a right-angled triangle, never in an acute or obtuse one. Second, in the formula, C must always be the hypotenuse, the longest side, so never place a shorter side there. Third, square each side first and then add. Squaring the sum gives the wrong answer. And finally, two triangles with the same area or the same perimeter are not always congruent. Congruence needs the sides and angles to match. Keep these in mind and your triangle work will stay accurate. Here is a quick summary of the key ideas. By their sides, triangles are scalene, isosceles, or equilateral. By their angles, they are acute, right-angled, or obtuse. Pythagoras' theorem says a squared plus b squared equals c squared, where c is the hypotenuse opposite the right angle. The same theorem in reverse tells us whether a triangle has a right angle, and two triangles are congruent when they pass one of the tests: side, 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 angle, side, angle, side, angle, or right angle, hypotenuse, side. Now let us check how much you remember with 3 quick questions. Here is the first question. A triangle has sides of 7 centimeters, 7 centimeters, and 4 centimeters. What type is it, judged by its sides? 2 of the sides are equal, both 7 centimeters, while the third is different. Exactly 2 equal sides means the triangle is isosceles. Question 2. A right-angled triangle has legs of 9 centimeters and 12 centimeters. Find the hypotenuse. By Pythagoras, we square the legs and add. 9 squared is 81, and 12 squared is 144. Together that is 225. The square root of 225 is 15, so the hypotenuse is 15 centimeters. Last question, and this one uses the theorem in reverse. Is a triangle with sides 8, 15, and 17 right-angled? We test the two shorter sides. 8 squared is 64, and 15 squared is 225, which add to 289. The longest side, 17 squared, is also 289. Because they are equal, the triangle is indeed right-angled. The answer is yes. Wonderful work. You can now classify any triangle by its sides and angles. Use Pythagoras' theorem to find a missing length and recognize when two triangles are congruent. Take a moment to practice a few problems on your own. In Module 8, we build on this to explore perimeter, area, and volume. I'll see you there.